This is an old newspaper. It has become dull and looks different from today's newspaper. But how did the color of the newspaper change? Let's find out.
Paper is made from wood which contains lignin. When lignin is exposed to air for some time, it undergoes oxidation and the paper turns yellow. Do you know what oxidation actually is? Oxidation can be defined in terms of oxygen, in terms of hydrogen, and in terms of electrons. Let's explore them one by one. In terms of oxygen, oxidation reactions are the reactions in which addition of oxygen to a substance takes place. Here, oxygen is added to magnesium. In terms of hydrogen, oxidation reactions are the reactions in which removal of hydrogen takes place. In this reaction, hydrogen is removed from hydrogen sulfide. All the compounds do not have oxygen and hydrogen, but they all contain electrons. Therefore, oxidation reaction can also be defined as the reactions which involve loss of electrons. Here, sodium atom is losing an electron to form sodium ion. Similarly, ferrous ion loses one electron to form ferric ion. Now we know that reactions involving addition of oxygen are known as oxidation reactions. Do we also have a specific name for reactions involving removal of oxygen? Yes, these reactions are known as reduction reactions. Reduction reactions can be defined in terms of oxygen, in terms of hydrogen, and in terms of electrons. In terms of oxygen, reduction reactions are the reactions which involve removal of oxygen. Here, oxygen is removed from copper oxide. In terms of hydrogen, reactions which involve addition of hydrogen are known as reduction reactions. In this reaction, hydrogen is added to chlorine. In terms of electrons, reduction reactions are defined as the reactions involving the gain of electrons. In the given example, a chlorine atom gains an electron to form chloride ion. Ferric ion gains an electron to form ferrous ion. It's time to recall and summarize what we have learned about oxidation and reduction reactions. Now we will carry out oxidation reaction in the laboratory. For this, we will take 1 gram copper powder in china dish and heat it. After some time, you will notice that copper powder is coated with black copper 2 oxide. It happens so because oxygen reacts and adds to copper and copper oxide is formed. It means an oxidation reaction has taken place. Let us now pass hydrogen gas over the heated copper oxide. Notice, now copper oxide is converted into copper. During the reaction, copper oxide loses oxygen and hydrogen gains oxygen. It means here reduction of copper oxide to copper and oxidation of hydrogen to water both have taken place. So we can conclude that sometimes both oxidation and reduction reactions take place simultaneously. These type of reactions are known as redox reactions. Let's consider some more examples of redox reactions. When zinc oxide reacts with carbon, zinc metal and carbon monoxide are formed. Notice in this reaction, carbon is oxidized to carbon monoxide and zinc oxide is reduced to zinc. Similarly, manganese oxide reacts with hydrochloric acid to form manganese chloride, water and chlorine. In this reaction, hydrochloric acid is oxidized to chlorine gas, whereas manganese oxide is reduced in manganese chloride. Since redox reaction involves both oxidation and reduction, therefore, in redox reactions, both loss and gain of electrons takes place. Here are some examples of the same. Remember, during redox reactions, number of electrons lost is equal to the number of electrons gained. Oxidation reactions play an important role in our daily life. Corrosion of iron and the rancidity of food are common examples of this category. Corrosion is the process in which metals are eaten up gradually by action of air, moisture or chemical on their surface. Rusting of iron is an example of corrosion. The black coating on silver and the green coating on copper are the other examples of corrosion. Corrosion damages the bodies of cars, bridges, iron railings, ships, and all the other objects made of metals. Since corrosion is a destructive process, therefore it is essential to prevent metal objects from corrosion. It can be done by painting metal surface, by greasing or by galvanization. Now, let's talk about the other common oxidation reaction known as rancidity. Rancidity is the deterioration of fatty and oily food by the oxidation, leading to unpleasant smell and taste. Presence of traces of metals like zinc, iron, etc., light, water, bacteria and molds speed up the process of rancidity. Rancidity affects the quality of the food, so it is essential to retard this process. It can be done by using airtight and light-protecting packaging, by using antioxidants like vitamin A and C, by using spices as rosemary and sage, by filling nitrogen gas in chips container.